Hello everyone. On the previous session, we discussed the graph of sine and cosine and how they relate to each other. On this session, we're going to talk about their transformation and how we can their graphs as well. Before diving into the transformation, let's recall the basic form of these functions. Y equal to sine of x and y equal to cosine of x. Both functions are periodic, meaning they repeat their values at regular intervals, and they oscillate between -1 and 1. Now we want to understand transformation. Transformations change the appearance of a graph without altering its fundamental nature. The general transform equations for sine and cosine are transformation for sine and cosine. The general formula for sine is y equal to a sine of bx plus c plus d. And for cosine, we have a cosine bx plus c plus d. Each parameter of a, b, and c affects the graph differently, and we're gonna break down their meaning. Okay, so the first term that we want to discuss is the amplitude of these transformations. The amplitude of these functions is shown by the value of a on both of these equations. The amplitude of the function is the maximum distance from its peak to its center line. And we're gonna illustrate it on an example. So let's look at the graph of sine. As you guys remember, the sine of x had this graph. And these values were 1 and -1, which the function tended to oscillate itself between those two values. So if we measure the maximum distance from its peak to its center line, which is the x-axis, it would be this distance, which this distance is the amplitude of the function, which is equal to 1. And for the cosine is the same. If we didn't want to graph the function for sine, we could easily use this value of a to determine its amplitude. The value of a for this example is equal to 1 because the coefficient that the function of sine has is 1. As you guys see here, there is a coefficient of 1 in here, which means a is equal to 1. So that gets us the same answer. And we wouldn't have to actually draw the graph in order to find its amplitude. Now, we want to talk about the values for these amplitudes in general. The a could be more than 1. A could be between 0 and 1. And a could be less than 0, which is a negative value. If a is actually more than 1, it means that the graph of these functions, the graph of this transformation is going to be stretched vertically. How? As an example, we want to draw the graph of 2 sine of x. We first gonna draw the graph of sine of x itself, which is looking like this. Now, on here, the a value is equal to 2, which is more than 1. What happens if there is a coefficient of 2 applied in here? The amplitude of the function would be stretched vertically in both of the sides. So it would be looking like this. Because as you guys seen here on the previous example, a is equal to the amplitude of the function. So the new function would have an amplitude of 2 and minus 2 in here. So the graph has actually been stretched vertically. So it is stretched. Now, what happens if the a value or the coefficient of sine was a value, for example, 1 over 2? So we want to draw 1 over 2 sine of x. Again, we're gonna draw the sine of x. Again, which these values are 1 and minus 1 as in the previous example. Now, if we actually have a coefficient of a equal to 1 over 2, the amplitude now is gonna be compressed vertically. So it would be looking like this, which these values are 1 over 2 and minus 1/2. So as you guys seen here, the amplitude of these functions have changed and it has been compressed. Now, what happens? A is a negative number. For example, we want to draw the minus sine of x. Now, we're gonna actually first draw sine of x again. And now, since the minus value is actually implemented behind the total of the function, the graph is reflected across its x-axis. So if we want to reflect the graph because of this minus value, it would be looking like this, which these values are 1, these ones are minus 1. As you guys see in here, the amplitude of the function, the value itself has not been changed, only it has been reflected. So the sign of this amplitude has been changed. So I'm gonna say if a is a negative value, it's going to be reflected. Now I want to explain the relationship between these amplitude changes and the power of these waves, and how is it helpful actually to know what is the amplitude of each wave, and how it can actually affect the wave's strength. So there is a proportional relationship between the power of the wave and its square of its amplitude. There is a direct relation between these two. So that means if the amplitude, for example, increases by 2 or it doubles, the power is going to be increased by 4. So let's say that the power of sine x is equal to p. Now we're gonna decide how is it gonna affect the power of sine when we actually change the amplitude of the function. Now, as you guys see in here, there is a coefficient of 2 behind sine. So that means the amplitude has been doubled. If the amplitude is doubled, the power is gonna be increased by a factor of 4. So the new function, which is 2 sine of x, has the power of 4p. So the power of this wave would be equal to 4p. Now let's look at the second example. We have 1 half sine x on the next example. As you see in here, the amplitude of the sine x has been halved. So if the amplitude is halved, the power decreases to 1/4 because this one has a power of 2. So 1/2 to the power of 2 becomes 1/4. So that means the power decreases to 1/4. So the power of 1/2 sine x is now equal to 1/4 of the power of the sine x. Now for this one, as you guys see in here, the value of the amplitude has not been changed. The value itself is still 1, and since a is to the power of 2, negative doesn't have any effect on it. So the power is still the same. So the power of minus sine x is equal to p still. So based off these examples, we can see how the amplitude change can affect the wave's power. And if it is more than 1 and it is a stretch, it means that the power is gonna be increased. And if it is between 0 and 1, it means that the power is going to be decreased. And if it is only a negative 1, it is being reflected, but the power doesn't change. Okay, now we want to discuss the b value of the general formula for the transformation of the functions and how does it affect the functions. So first let's look at the general formula of the transformation of the functions, which were these two formulas. Now we want to discuss a term which is called the period of the function. The period of the function, which is shown by the capital letter of t, is the distance of which these functions have to take in order to complete their full cycle. So if you want to calculate t based off the formula, you would eventually use this formula, which is equal to 2 pi over the absolute value of b. And b in here is the coefficient of x. So if you find the coefficient of the x and you take the absolute value of b and put it in here, you can get the period of the functions. Now let's look at the graph of sine and cosine. As you guys see in here, we mentioned period is the distance of which the function completes its full cycle. As you guys see in here, the distance for the first one is 2 pi, and the distance for the second one, which was cosine, is 2 pi as well. So these both functions complete their full cycle when they reach to 2 pi. So this one was sine and this one was cosine. If we didn't want to actually draw their graphs to find at which value they tend to complete their full cycle, we can use this formula easily in sine of x and cosine of x. Yeah. Based off these formulas, as you guys see in here, the coefficient of x for both of these functions is equal to 1. This one is 1 and this one is 1. There is a 1 which is not visible in here because we don't usually write 1 behind the function, behind the variable. There is a 1 behind each of these x values. So that means that the b value for cosine is equal to 1, and the b value for sine is equal to 1 as well. So if we wanted to use that formula, we could write the t value is equal to 2 pi over 1. So we have two ways. The first way is that we actually visualize the graphs, but the easiest way is actually to use this formula. As you see in here, we get the p values and we just divide 2 pi by 1. Now I want to discuss the relationship between t, or the period of the function, and its b value. As you guys see in here, when b is in the denominator, it has an inverse effect with t. So when b actually increases, that would get us to t decreasing. And if b decreases, since they have an inverse proportionality, that would get us to t increasing. To better understand these concepts, we're gonna draw two different graphs. The first one would be y equal to sine of 2x, and the second one would be equal to y sine of 1 over 2x. For the first one, we're first gonna calculate its period, which is equal to 2 pi over 2, which is equal to pi. And for the second one, we are going to do the same, is equal to 2 pi over 1 over 2, which is equal to 4 pi. As you guys see in here, the period of the function on this one has been decreased, and the period of the function on the second one has been increased. So the second one is actually going to spend more distance in order to actually complete its full cycle. But the first one is actually gonna complete its cycle on less distance. Now let's draw these functions. As you guys remember, I'm first gonna draw the sine of x, which was looking like this. This was 2 pi. Now, if we actually, instead of completing the function at 2 pi, we complete the cycle at pi, which was this value, we would eventually get to this function. So what I would do now is actually gonna compress this function. I'm gonna compress this function. As you see here, I'm gonna compress it till we get to pi. As you can see in here, this function is actually has completed its full cycle at pi. So this is the function for sine of 2x because it has completed its full cycle at t equals to pi. Okay, now we want to investigate what will be the graph for the second one as well. For the second one, I'm gonna do the same again. I'm gonna first draw the sine of x. And for sine of x, it was looking like this, which was 2 pi at this point. I'm gonna actually continue the x-axis in here to get to 4 pi as well, because eventually we're going to get to the 4 pi value since the period of the function is 2 pi. Now, and these values were 1 and -1 for both of them, because the function is going to be changed only horizontally, it doesn't affect its vertical axis. So now what I want to do, as you guys see in here, first of all, the sine of x completes its full cycle at 2 pi. Now we want the sine of x to complete its full cycle at 4 pi. So what we would need to do is actually need to stretch the function of sine horizontally, so we get to the 4 pi value. So if I stretch it like this, it's gonna be completed like that. So this function now is looking like this. I'm gonna shade it so we can better see the sign of x. And as you see in here, it completes its full cycle as 4 pi, and this one completed its full cycle at pi. So if we can conclude that if b is more than 1, we need to compress the function horizontally. And if b is less than 1, we need to stretch the function horizontally. Now you might think, why do we even need to calculate the b value, and how is it practical in a real life scenario? Well, if we actually can control the b value, we can control how fast or slow the wave is. If the b value is increasing, as I said before, it means that the period of the function is decreasing. So that means the wave is completing its cycle in less time, so it moves more quickly. And based off that, it has higher frequency. So if you need a high frequency wave, we can use a higher b value. And if you need a low frequency wave, we can use a lower b value. So based off the frequency that you need in a real life scenario, you can control the b value. It is crucial for designing stable structures, efficient communication systems, and medical diagnosis, for example. Okay, now let's talk about the value of c and what does it show. The value of c is the horizontal shift or phase shift of the primary or the initial function that is going to be transformed to another function. So the c value could have two types of values. It could be a positive value, which c is more than 0, and it could be a negative value, which c is less than 0. If c is more than 0, in order to draw the function, we are just gonna shift the function to the left by the value of c. So we say the function is gonna be shifted to the left side by the value of c horizontally. And if the c is a negative value, it's going to be shifted to the right horizontally by the value of c. Now we're gonna show you some examples, and we're also gonna show you what does a phase shift mean. So for now, we're gonna draw these two functions. The sine of x plus pi over 2 and the sine of x minus pi over 2. First, the c value in here is the positive value because c is equal to pi over 2. And the c value on the lower function is less than 0, which is a negative one, because c is equal to minus pi over 2. In order to draw these functions, we first are gonna draw the initial function, which is the sine of x. Then we are gonna transform the sine of x to the given formula. So first we're gonna draw the sine of x, which is this one. And we're gonna just copy it because both functions are sines. We're just gonna copy this one and put it on the below one as well. Now, as we mentioned before, if c is a positive number, the function is going to be shifted to the left side. And if the c is a negative value, the function is going to be shifted to the right side. So we're gonna shift this function. I'm gonna name the values in here, which are pi and 2 pi. So if we want to shift this to the left by pi over 2, remember that this value was pi over 2 as well. We are just gonna take this function, just gonna shift this by pi over 2, which will get us to this point. If you actually move each of the initial points by pi over 2, you get to this point. The initial point, for example, for the first one was like this. The peak one, the first peak was like this. Then it moved by pi over 2 to this side. And also, if you want to move this function by pi over 2 to the right, this one is pi over 2. What we can do is we can just move this function to the right. Because as you see in here, the initial point, for example, at 0 was like this. Now the initial point is like this. So this is how the function would like, but in order to complete the cycle, we have to extend the function to the left and right as well. To do that, we are just gonna copy this function and just paste it onto this left side and onto this right side. So it could be looking like this. And if we do the same for this one as well, it would be looking, it would be looking like this. As you see in here, both of these functions oscillate between 1 and minus 1. So the amplitude has not changed, but the function has been shifted to the left side on the first one and just shifted to the right side on the second one. Now we are just gonna talk about the phase shift, which is the same as the horizontal shift. But as we state phase shift, we use some terms like delay and advance. If the initial starting point of the function starts earlier than the usual time, it means that the function is advanced. And also, if the wave starts later than its usual, it means that the function is delayed. Now let's look at which one of these are delayed and which one of them is advanced. To understand this, as you guys remember, the initial point for both of these functions were these ones, right? And when we shifted the function to the left, the initial point was like this. It became backward, right? The initial point moved pi over 2 to the left. And also for this one, when we shifted to the right, the initial point moved to this point. So actually, the first one, it moved back by minus pi over 2. And this one moved by pi over 2 to the right, plus pi over 2 to the right. So it means that on the first one, the initial point actually started earlier than the usual, because it should have been started at the 0 point, but it started at the minus value, which is actually earlier than the 0 one. But the second one, the initial point, which should have started at 0, it actually started at positive pi over 2. So it means it had a delayed. So we can say that this one was delayed because it started later than its usual. It started at pi over 2 instead of 0. And this one, it should have started the function at 0, but now it is started at theta equals to, for example, minus pi over 2, which is now showing that the function is advanced. So we can say that if the c value is more than 0, it is indicating that the function is advanced. And if the c value is less than 0, it is indicating that the function is delayed. Now we are going to look at the last value, or the last variable, which is d. d on these transformations shows the vertical shift of the function. d is equal to vertical shift of the functions. So if d is positive value, it means that the function is going to be moved up. And if d is a negative value, it means that the function is going to be moved down. The d value is actually going to just move the whole function to the upside or the downside, and it's going to move its center line as well. So in order to draw these functions, you can just simply move the center line of the function by the value of d to the upside or to the downside. So let's, for example, say we want to draw sine of x plus 2, and also we want to draw sine of x minus 1 as an example. For the first one, we are first gonna draw the sine of x as always, which would be looking like this, which this one is 1 and this one is minus 1, and the center line is at the x-axis. So if you want to move the function, we should move it upward by the value of 2, because d in here is a positive value since d is equal to 2. So we just are gonna move the function upward by the value of 2. And for that, I'm gonna know that since the center line in here is equal to 0, the new center line is gonna be this one. If I actually continue drawing the y-axis, the y-axis would be looking like this, and this value would be equal to 2. So the new center line of the function would be this one. And for that purpose, I'm just gonna select the function and I'm just gonna move it in here. Since this is the new center line, the function would be looking like this. Its minimum value would be 1 and its maximum value would be 3. And the period of the function on the x-axis wouldn't change. Only the y is going to be transferred to the upside. Now, for the second one, we are just gonna draw the sine of x again, which would be looking like this. and the center line is again at 0, and this point is 1, this point is -1, and for this purpose we are just gonna draw the new center line as well. The new center line would be this line, since it is going to be moved down, since d value is minus and it is a negative one, it's going to be moved down, and the center line would be at -1. So I'm just gonna move the function down to its center line. So it would be looking like this, and these of the maximum value would be at 0 and the minimum value would be at -2.